let's see what happens when CO2 goes into oil. The reason that this is different is because oil is non-polar. And this could be messy. Yeah, keep adding as much as you can fit. Oh good, we're going to be able to get it all in there. This is like a mole of CO2. Look what's happening. So now notice, does it look the same as it did in water? Ian, does that look the same? It's going to bubble over. That's okay. Let's see, that's probably good. That's probably good because it's going to bubble over a lot of oil.
Okay.
So look what's happening there. It's producing the same, the oil is warming it up and it's producing the same bubbles, but I think there's a little bit of a difference on the surface. Let's see. Because oil is non-polar, okay? Now, isn't it interesting that, look, this is producing none of that, right? None of that effect you usually get from CO2. That's the big difference, isn't it? Isn't it? Because look, because there's no water here, we're not seeing what's going on up here, but it should be really cold. Interesting. So notice how we don't see any of that cool effect because the CO2, this shows you, do you know what this shows you? That the CO2 coming out is invisible. What you're usually seeing is the water, right? But since there's no water, you don't see it. Interesting, right? What I was thinking would be more different would be the surface. But that actually still looks very much like a mirror, like on the surface.
Yeah, like the water.
So that doesn't look too different. But the big difference is up here, right? You don't see any of that. Any of that. So I wonder if we poured a little water in there. We'll do that in a minute. We'll pour some water up here and see if we see it. Okay. So now we want to see what happens if Ian pours a little bit of water into there and see if that changes the effect. If we can see the water coming out. Let's see.
Is that good?
Yeah, a little more.
Okay.
Let's see, now do we see the effect? Interesting, right? Interesting, we still don't. Because it's not able to get the water to the correct temperature. I think that's really neat.
Yeah.
That's what's happening. So this proves that what you're seeing when dry ice is subliming, what you're seeing coming out is the water. Because look, nothing. CO2, invisible. Wow. Cool. Okay, so now we're going to try something interesting. This could make a mess also. Ian, add some of the soap into the water. Okay, that looks good. And Lucy, could you stir that up with the stir rod? How about that one? Stir it up. Now, what do you think is going to happen if we put dry ice in there? So this will be interesting, right? This could make a mess, but you know what? We can clean it up. Okay, let me move these water molecules out of the way. Okay. Oh, by the way, the reason that CO2 molecules boil so quickly is because even though they have polar bonds, the molecule is nonpolar. So the different CO2 molecules, they just barely stick together. So it's easy to get them. Okay, so now drop a whole bunch of CO2 in there. Let's see what happens. Ready? I want to turn it so I get the clear side of the beaker. Ready? Okay, here we go.
Whoa.
Oh, there's no big chunks?
There were.
I was hoping a chunk would go under. Okay, I'll get you another chunk. I didn't expect it to sit on. Oh, wait, you know what? It's not going through the soap. That's what's happening. It's sitting on top of the soap. It's sitting on top.
Whoa.
Isn't that interesting?
Yeah.
Let's get a big chunk and see if we can get what happens when it gets under the
Oh
soap.
my gosh, you're right.
Isn't that neat?
Oh, there's one here.
No, we need something bigger than that. Okay, yeah, drop that. Yeah, drop that. Try to plunk it in. Plunk it in hard. Oh, so it breaks the soap. Like drop it from above, like from a little bit above so it plunks down. Push it in. Yeah, drop it.
Push it.
Oh, like this.
Push it.
Boom! No, we need a bigger chunk. Okay, so Ian, we're gonna drop that in. Let's see what happens to the soap water.
3, 2, 1.
Oh! It's okay.
Okay.
You don't have to drop it from above. It's heavy enough that it'll
1,
go.
2, 3. Whoa.
Oh, this is what I thought might happen. That's cool. So when it's under, this is what I thought would happen. This is what I was expecting. Okay, lots of frothy bubbles. Lots and lots of frothy bubbles. How many bubbles do you think we're gonna get?
More than 100?
I can't count that high.
I guess that'll clean up any oil that is spilled. Try to scoop it out. Try to lift it out, Ian, if you can, and see how it looks like when you pull it out. No? Okay, no, Lucy, not you. Can you get it? Lift it up. Oh, how does it look? Interesting, right?
It looks like bubbles.
Now another thing, okay.
A volcano.
Yeah, it's like a volcano, right? Put it back in.
Ooh,
Look at that, right?
growing again.
See, this is what I sort of expected. This is kind of what I expected, right? Lots of bubbles, making lots of soap bubbles.
Is that why you said it was going to make a mess?
I thought it would make a mess, yeah. This isn't too bad, though. It's just a bunch of soap foam, right?
But it's still a lot. We're just dropping
Let's see, now what should we do? Let's take that cube of dry ice out of there, because it's going to make too much mess. Let's scoop it out again. And let's put it into this. Put it into there.
Oh, okay.
Okay, so now, okay, is that a mess, guys? Is that a mess?
Yes.
So look at the surface of this. Interesting, it's got soap on it. Interesting, I wonder if that speeds up or slows down the sublimation. I think I'm gonna leave this piece sitting there. Okay, now Lucy, let's put some in, since we did oil, let's do some vinegar. Let's put some in vinegar. Now vinegar contains some water, so maybe, okay, open that and then use the tongs to put pieces that'll fit through the neck, maybe. If any pieces will fit through this neck, I'm gonna turn it so I can see this side. If it's small enough to, yeah, put some in. Oh look, because it has water, look. Do you see that, Ian?
There, plug my nose.
Well, I wonder if it's gonna smell like vinegar. Let's see. Can you smell it?
So far, yeah.
I can smell it. But that looks cool, right? This would be like a cool movie effect. Like Dr. Frankenstein, you know?
Yes.
It's alive! It's alive! That is a cool effect. Vinegar. Okay, let's see. It's gonna go over the top. It's gonna make a mess, but that's enough. That's enough. That's enough. That's enough. So oil and vinegar, interesting. So we did oil and vinegar. Now what you're gonna do
Doesn't
is
smell
we're gonna.
bad.
No, it does smell. It's balsamic vinegar, so it smells like that, right? This is balsamic.
Yeah.
Interesting, but it's acetic acid anyway, and it's splattering a bit. I better move some of these back. It's splattering around. Most of these things are waterproof. So what we're gonna do is we're gonna put natural sand on this one. Can you scoop some natural sand on this one, Lucy, with a spoon?
Sure.
Scoop a little, and Ian, scoop some space sand on this one and see how it looks. Let's see if they act the same way. Only on this one. Wait, I gotta see it. I gotta see it.
So
Okay.
I put it in here?
Yeah, on this one. Yeah. Scoop. See what happens. Spread it out though. Try to spread it on top. Like get another scoop. More. Let's see what that does to the dry ice, because both of those, the polarities are interesting. So, okay, that's probably enough. And then let's see what happens. Let's watch them for a bit and come back and see what happens. Okay? Now, other experiments we can do. What else can we do? You know what, Lucy, what I would probably do to help this one along is take some of these chunks and fit them anywhere they fit around this, because there's just not enough dry ice around that. Just don't get them into the actual beakers. It just seems like it has to be more like surrounding them. And look at the vinegar going. Cool, right? Cool.
Okay, let's.
Go into.
Yeah. I think I'm just gonna grab them and put them here. scissors.
You can use a spoon.
There's a better one.
Okay. Whoa. Is that good?
Can you say, it's alive?
No.
Can you say, Frau Blucher?
No!
So is that enough for?
Do that again.
Wow. I have to watch out.
The whirlwind. Inherit the whirlwind. So we're going to go outside and try to make some more liquid CO2. And then we'll come back and see if those are frozen. So how's this looking? Oh, interesting. Interesting. Both of them look kind of like glaciers. Dirty glaciers. It's the way glaciers melt. The warm sand is melting into them. It doesn't seem to make too much difference whether it's the natural sand or the space sand. I'm going to put them right next to each other. Doesn't seem to make too much difference which one it is though, does it? Which is interesting because space sand is non-polar like dry ice and natural sand is polar. Interesting, right? Okay, so we're putting that back in the soap. Put it in the soap. Just a little, lower it slowly. A little bit, for a little bit. Let go a little, like widen it. Let it coat it. Yeah, we got to get that coating on it. And let's move this back away. That's interesting. So we produce some kind of weird coating onto the CO2. I wonder how long that's going to last. Okay, now Ian, take it back out and put it in that. Carefully.
Back in here.
Into there, yeah.
Okay.
Okay, and just plop it in there. Interesting. Oh, okay, I hope you didn't drop it too hard. So hopefully that has that layer on it. Interesting. So, what are we going to do with this one? That is so cool. I think that crust prevents it from subliming a lot.
That's actually.
So what we're going to wind up with, Lucy, when it's all gone, is a crust to still be there. I want to do that with this one too. Ian, Lucy, I'll let you do it. I'll let you do this one. Okay, so Lucy, we're going to try to make, now that we know this happens, squeeze that. Got it?
Yeah.
Now that we know this happens, we're going to try to make another one. So you're going to put that into the soapy water. We're going to try to make another crust. And what we're hoping, just drop it in. And once it's coated, let it stay in there for a bit. Once it's coated, I think what's going to happen, my guess is, that when all the dry ice is gone in there, that you'll have this crusty shell, the same shape. It's like a fossil, right? Is that so cool? So when you're done, when that's been in there a little bit, you're gonna drop it in maybe next to there. These are the ones that had soap. Okay, and we're gonna get ready to do some more liquid CO2 now. Cool, right? Let's see, how long, maybe turn it a little so it's turned around. No, like that one. Like rotate it. So all the sides are getting.
I'm gonna go wash.
No. That's got soap anyway. I think that's enough. Oh, these are gonna get. Okay, so put it in there, Lucy. Put it off to the side. Like pick it up. Let the water drip off it for a second. Oh, hold it up above the beaker. Hold it above the beaker. Hopefully that has that crust. And then slowly lower it into there, off to the side. Cool, right? Okay, so now if we're lucky, that will have that crust on it. Interesting, we'll have to think about what that crust is. So, I'm gonna lower this dry ice, see the dry ice, into the water. The water's gonna warm it up. I'm probably gonna get splashed a lot, and I'm gonna hold it near the front so you can see the liquid. When it's liquid, you'll see it flowing around. So try to get a close look. Look, it's doing it. Get close, please. See the liquid CO2? Definitely. Look at that. It's about to pop. Oh, that wasn't a bad pop. It wasn't a bad pop, but we had liquid CO2. Could you see that? I could really see it.
Yeah.
Well, good thing is we got more of these. Okay, let me plop that one in there for now. Let me get the second one. Great, I think that'll do it. Okay, ready? We're gonna do it again. Make some liquid CO2. Now notice that it's solid right now, but when it gets to that 5.11 atmospheres, oh look, there it goes. There it goes liquid, look, totally. It's gonna pop, oh, there we go. Very good, that was an excellent one. I could really see it sloshing. Let's do another one. Okay, ready? That'll be an interesting one. Okay, ready? So now, it's not liquid yet. It's not liquid yet. It's a tight seal, I think. Oh, it's melting. You go up. Oh, look. Oh my gosh. Liquid CO2. Do you see that? Liquid CO2. Definitely see it.
No,
That means there's more than 5 times Earth's atmosphere in here. Oh my gosh. I managed it. I got it out before. Look, see the liquid CO2 in there? Can you see it? Can you see it? Okay, I'm going to hold it in front of this. See the liquid CO2 in there? No, the only problem is that it's dirty. Like, oh! Did that spray you?
Yeah.
Okay. So now, good one, right? Ready for it to burst? I'm ready. Brace yourselves. It's going to burst. Oh, that was a good one.
It rained
We're
on
so
me.
wet.
Okay, now, wait, there's another thing. Let's see what happens when I drop this in there. And I'll drop this into there. Get a close-up shot. That's not going to explode on me. Okay guys, we're going to do some more experiments. And the first one is now, Lucy, I want you to put some chunks of dry ice out of that one into the oil and water, and we'll see what happens. Put some chunks that'll fit through the neck. Get a chunk that would fit through that neck. It's screeching, but there we go. Oh look, so it does now make the effect because of the water on the bottom. That's cool. Now this looks like another good like mad science experiment, right? Okay, Lucy, that's probably good. That's probably good. So look what's happening. The water on the bottom, okay, is what is actually heating up the dry ice. And then some of it must be rising up through the oil with the dry ice, with the carbon dioxide, and then it's visible up there. So that's kind of an interesting way. So you can do it with oil and water, just not with only oil. With only oil, it's invisible, right? Isn't that neat? Yeah. So that'll be our cool background effect. Now notice, hold on Ian, don't blow for a second. Notice how it's dropping straight down the side and over the table, isn't that cool? Now the reason it does that is because it's a cold gas. Okay, it's actually cold CO2, hang on. And because the water is carried along with it, the little liquid water drops are carried right along with it. So that's why they're sinking. Okay, so the next thing we want to do is we want to see if carbon dioxide turns the water into an acid. So Lucy, could you unscrew that universal indicator? Remember, universal indicator. And put a big squirt into there until we can see the color. Maybe a couple squirts. Down into the liquid, straight down. So what color is that?
Green.
Okay. Put up another squirt. We want it to be very visible. Okay, that's good, that's good. And so that indicates neutral, right? Indicates neutral. And we're gonna see what put a chunk of dry ice that fits in there, or a couple chunks, and drop them in there, and we'll see what that does to the color. Another one, another one. See what that does to the color. More. Oh, what color is it now?
It's turning yellow.
Okay, more. Put another one.
Sort of orange now.
Orange.
Yeah.
It's kind of going through the spectrum. Okay, that's probably enough to see. Oh yeah, so now...
It was sort of turning red. But it was turning.
Interesting, right? So what do you think that means based on this universal indicator scale? What does that mean? If it's turning orange?
That would be an acid.
And is it getting darker and darker? Is it getting more and more orange and red?
Yeah.
So do you think Ian could do that same thing? Do you think Ian could have the same effect? Do you know why? Because Ian is respiring. He is breathing. And when you breathe, one of the things you exhale is carbon dioxide, just like that. So I wonder if Ian could do the same thing. He's going to do that over here. But first, I want to check one of my favorite drinks, Lucy. San Pellegrino, could you take that and hold it up carefully? Don't shake it. Okay, so San Pellegrino is a carbonated beverage, right? And we're going to check whether it is an acid or a base or neutral. Lucy's going to pour in a bunch of it in here till it goes up to that 200 line. Just in this one, Lucy. Do you think you could do that, Ian? Could you do that? Pour it up to that top line. So there's San Pellegrino. So what's happening there, do you know what's happening in San Pellegrino? The carbonic acid is breaking into water and CO2. So that is producing CO2 also. It's releasing it. People say that it's carbonated, but it's actually in the form of carbonic acid, H2CO3. So carbonic acid is in the Pellegrino, and let's see if that makes it, if it really is an acid. Put a squirt, just like you did there, Lucy, put a squirt in there. I'm gonna have Lucy handle the universal
I
indicator.
just want to know if I should carry this.
I don't know if we need to measure our mass again. Let's see. Let me think. Put a good squirt in. Never hurts, Ian. Yeah, you can tear it. So what does that tell you? Look at the color. What does that tell you, Ian?
It's sort of.
Look at this. What does that tell you?
It's sort of like.
It's an acid?
Yeah.
It's an acid, right? So Pellegrino is an acid right now out of the bottle, carbonic acid. Could you stir that, Lucy, with that stir? So it gets consistently red? Because the indicator tends to stay at the top. Okay, stir it around. So that proves that Pellegrino is an acid. Now, by the way, if you let Pellegrino sit, I've done this before, if we let that sit over time, okay, that's good. As the carbonic acid breaks apart, it gets to be less and less of an acid. And if you leave that sitting long enough, eventually it's just neutral. So like flat Pellegrino or like Perrier, right? It would turn back to being neutral, okay? And now what we're gonna do is we're gonna do the same thing. Now, Ian, you gotta be very careful here. I know how you love to blow bubbles. You're gonna blow bubbles through this straw into regular water, right? But you can't swallow it, only blow through it. And don't push it right down. Hold it up a little bit off the bottom, okay? And you're gonna you're gonna try to change it into an acid like this. So Lucy, put some universal indicator drops, a squirt in there. This is one of those Bill Nye experiments. So what color is that? Stir it up, Lucy. That's enough. Stir it in there.
Sort of green.
Sort of.
Dark green.
It's very green. So what does green mean?
Neutral?
Neutral.
Green means neutral, right? So Ian is going to, with his mighty, mighty acid breath, he's going to turn. Wow, that's a perfect green. I don't think I've ever gotten one that came out that perfect. Better use it quick. Okay, so Ian, you're going to only drink the side of the straw that's bent like that. You're not going to drink, of course. You're only going to blow on this side, and you're not going to let it splatter too much. You're going to blow bubbles lightly near the bottom. Okay, don't let it froth up. And then we'll watch what happens to the color. You have to hold it. Make sure that I can see the color. Okay, I need to be able to see the color. Okay, only blow bubbles. Get ready? Go. He loves to do this. He does this anyway. Just don't swallow it, of course. Let's see what happens to that green color. Keep going.
I can smell it.
Okay, now step away from the straw for a second and take a few breaths so you don't hyperventilate. What's happening to the color, Lucy?
I think it's turning lighter.
Lighter? Let's see. Okay, so let's keep going.
Okay.
Okay, let's see. Let's see how it is. Step away. Yeah, I think that's noticeably orange. That's acidic. Let's see. Is that as orange? That's pretty orange. Ian, move your glove. I want to have if we had a white background. Do you have anything that has a white background? Get a paper towel, Lucy, and hold it behind it so we can see the color better. Just hold it behind it. Yeah, so that's noticeably orange. And then do the same thing over here. Okay, there's the Pellegrino. And then this is the one that the carbonic acid made. Oh my gosh, look at this balloon, guys. I hope that's in the camera above. Maybe I'll move it slightly in. Okay, so that's getting there. That's a mole of carbon dioxide. So isn't it funny that that little bit that we had in there produces all that gas, right?
That's the mole.
Okay, hang on. Lucy, so now we got a few more things we're gonna do. Lucy, why don't you drop a few more? Ian, why don't you drop some chunks into the oil and water? Let him drop some chunks. Give him the tongs. Just for fun.
So in here?
Yeah. As long as it fits through the neck. The metal is screaming in pain. Because the metal is being chilled along the surface. That's why it's screeching. Will that fit? Oh, well, just leave it there. Just leave it there. That's okay. Once it sublimes, it'll drop. Ian, come here. There comes a time in every child's life where he earns the right to wield the mighty Mjolnir. Wait, you hold it up close to the top? Let's see, are you white? He's worthy. He is worthy. Okay, I bet Lucy's probably worthy too. Okay, Lucy, both of you guys can handle it.
And you.
Okay, and Ian is just gonna smash wait, let me clear this so I get a good view. He's just gonna smash some dry ice wielding baby Mjolnir. Go!
Okay. Whoa.
Again. Put a piece back in the middle.
Okay, can we just take a break?
So now, Lucy is going to smash some dry ice. I'll put one of those little chunks in here, so this will keep going. Put one of the chunks in there. Okay, there we go. And then Lucy's going to smash it, holding baby Mjolnir. Ready? You get a good shot. Set. Go! You can pick pieces up, put them back on. Smash them again. So when you get a little fleck of dry ice on your skin, it feels like you're getting the frostbite. Don't you feel that?
Yeah.
So get it off if it's on your skin. Are you done, Lucy?